How big could a wind turbine possibly be? The iconic Dutch windmills were only about 40 metres high, but we've come a long way since the 12th century, and engineers are now pushing the boundaries of just how big these structures can get. Wind turbines are now going up in Europe that are higher than some of the continent's tallest skyscrapers. But how are these enormous structures put together, and is there a limit to how big we can make them? Welcome to the age of the super tall wind turbine. Right now, there's a race to build the world's tallest wind turbine. In the last 3 years alone, the tallest of these prototypes has skyrocketed. These are far, far taller than the height of a typical wind turbine, which more or less stands 80 metres tall. This is the world's tallest wind turbine, for the moment. It was erected at the beginning of 2023 at a test facility in Denmark. It's 280 metres tall and has an absolutely enormous rotor diameter of 236 metres. That's 100 metres greater than the London Eye. The blades themselves are 115 metres long, each one taller than Big Ben. They were assembled at the nearby blade factory in Naskov and carefully transported to the site. Just one of these enormous machines is capable of producing 80 gigawatt hours of energy every year. That's enough to power around 20,000 European households and save more than 38,000 tonnes of carbon dioxide. That's equivalent to removing 25,000 passenger cars from the roads each year, and that's just one turbine. For comparison, just a couple of decades ago, the UK was lauded for building an offshore wind farm capable of producing less than 3% of what Denmark's latest turbine can. With numbers like that, it's no wonder these giant structures are becoming increasingly common. Not to be outdone, over in Germany, they're testing the limits of just how tall a wind turbine can be with this giant 300-metre high testing mast. Sprint, the company behind the test mast, has already said that these high-altitude turbines could produce twice as much electricity as smaller ones, and even hold multiple turbines at different heights, something the Norwegian Wind Catching Systems is already working on. They've proposed a 300-metre by 300-metre offshore wind farm, a gigantic square taller than the Eiffel Tower that would sit out at sea and produce as much energy as 5 of the strongest floating turbines in existence. So, how on earth did we get here, and why is there now a race to build the world's tallest supersized wind turbine? Well, as you know, there's a lot of urgency to switch to greener energy sources to reduce carbon emissions and fight climate change. For a long time, wind power wasn't seen as a viable alternative to producing power on the scale that we need it in. But that's steadily changing. In just the last year alone, power generation from wind has increased globally by 17%. And in the last decade, wind power has increased 5-fold. That's thanks to these larger turbines that can produce more energy for less cost. But it's not enough, and the race to build the world's tallest wind turbines is all about maximising. You see, there are 2 ways to get more energy out of a wind turbine, and therefore more money. The first is to have a bigger rotor and blades with a larger diameter capturing more of the wind. The second is to have the wind turbine higher up where the wind blows more steadily. Combining those 2 things is the most ideal. Not only will these mega turbines produce an enormous amount of energy, they'll do so for less. 250 metre high offshore wind turbines in the UK are already producing energy below £50 per megawatt hour, eliminating the need for government subsidies and making this type of clean energy competitive with other forms of power. Despite already having turbine blades the size of Big Ben, they could theoretically keep getting bigger. The bigger the blade is, the more energy it extracts from the wind. But there are other issues. In order to avoid erosion, the very tips of the blade cannot spin faster than 90 meters a second. That means the bigger the blade is, the slower it has to spin. Slowing the rotor down to accommodate these larger blades increases the forces put on the entire turbine. To combat these forces, the weight of the turbine has to increase, but this also increases the cost of constructing the whole structure. Eventually, there comes a point where the cost of the larger turbine would be more than the profit that could be made from it, and that's the ceiling we're going to reach with these structures, at least economically. Engineering-wise, the longer a blade gets, the more wobbly it is as well, making it harder to control in high winds. But experts are optimistic these kinds of design challenges could eventually be overcome. Once the engineering is sorted, the next important factor in wind capture is the location. And right about here just so happens to be the perfect place for consistent strong winds. The middle of the ocean. Now, you might look at these structures and wonder how exactly they're standing in the open water. How deep do they go under the waves? Well, they don't. They float. In waters deeper than 60 metres, these floating turbines are anchored to the seabed with multiple moorings. Ironically, these green energy producers modelled their floating turbines off floating oil platforms that use a similar engineering technique. Sensors and computers then regulate the turbine blades in relation to the wind gusts to ensure they don't tip over. There are a couple of different ways to accomplish this. The spar model is weighted at the bottom. Buoyancy then comes from the geometry of the cylinder, while stability is provided by this weight at the lowest point. Other models have the turbine on floating platforms or barges like these. Overcoming the logistics of shipping the gigantic parts of the turbine to their offshore location will be these megastructures' next major challenge. The blades must be shipped in one piece, which requires enormous ports, vessels and cranes capable of assembling them out in the middle of the ocean. The UK is already brushing up against these limitations. The country likely won't meet its ambitious 2030 target to triple its number of wind turbines. That's not because of the technology or a lack of offshore sites, but because the turbines can't be manufactured and assembled fast enough. Massive wind turbines like these are going to become increasingly common in the fight against climate change. Making them as efficient and able to produce as much energy as possible is paramount, and that probably means we're going to see even taller, skyscraper-sized wind turbines in the near future. You can learn more about this and other topics on our channel over on the World's Best Construction Podcast, available right now wherever you get your podcasts. And as always guys, if you enjoyed this video and you want to learn more about where construction is headed, make sure you subscribe to tomorrow's build.